My name is Jana Jenquin, and I am at the University of Florida. So I am a joint postdoc in Eric Wang and Andy Berglund's lab, and my fellowship year is 2020. The main focus of the work that I'm doing with regards to my fellowship is small molecule research in treatments and therapeutics for DM1 and DM2. What I have found is that a lot of the small molecules that I'm working with actually work to rescue missplicing and other disease phenotypes in DM1 and DM2. So another aspect of my work is that I am studying foci dynamics in DM1 and DM2. And it's been shown that both of the repeat RNAs, the CUG repeats and CCUG repeats, actually sequester RNA binding proteins. And so now I am sort of looking at the role of both MBNL1 and then also RBFOX, which are both RNA binding proteins, and RBFOX has been implicated in DM2, and sort of figuring out that dynamic between them and how they're binding and potentially competing for binding to the repeat RNA. In terms of the small molecule work, I think the main hope is sort of moving forward in figuring out, with these small molecules, what aspects of the small molecules, so what moieties, what functional groups are actually causing the action that we want. So what impact do these moieties have on rescuing missplicing in myotonic dystrophy models? And so we've actually been working a lot to work with different analogs of these diamidine compounds, and basically trying to design small molecules that have sort of increased missplicing rescue and increased activity, but decreased off-target effects to sort of lower the toxicity of these molecules. And the sort of overall hope is just moving forward with potential therapeutics. I think small molecules are a viable option. They're cheap to produce. They can be weaned on and off quite easily with patients if there are any adverse effects. And a lot of these small molecules that I'm working with actually can cross the blood-brain barrier and impact some of the cognitive effects that a lot of patients suffer from with myotonic dystrophy. And I think that's a really important aspect of the work. My hope is a therapeutic. I mean, right now, there are no disease-targeting therapeutics available for myotonic dystrophy. And I think people are working really, really hard. And I think we have a lot of great researchers that are doing a lot of fantastic work. And we're getting closer, right? It's baby steps, and sometimes it seems like it's taking a really long time. But yeah, my overall goal is to find a potential therapeutic. I think the Myotonic Dystrophy Foundation is basically what it means to me, is a bridge, right? I feel like as a researcher, a lot of times we can be a little bit cut off from the community. And the work that I do, I hope to one day directly impact patients with myotonic dystrophy. And so I really see the MDF as a bridge between research and the community, and being able to share the work that we're doing and, let patients know that we're working really hard. We really are. And we hope that this, pays off. The one thing that I would want, the DM community to know about my work is that I think what I'm doing and others in the research community are doing is really driving forward the search for therapeutics, whether it's going to be small molecules or gene therapy approaches. I think that just letting them know that we're working hard to find a potential therapeutic.